Good afternoon, everyone. Thanks for a very kind introduction. It's an honor to be here. I will tell you a little bit about what I've been doing, but also I will share some of our secrets to how we create devices like the Jaipur-knee that I will show you. And my company is called Remotion Designs, and our mission is to empower amputees who are missing limbs with prosthetics. So let me tell you a little bit about our story. Our mission is to revolutionize the way that amputees live their lives. We want prosthetics to be a symbol of beauty for an amputee, a symbol of courage, of confidence, even warrior ready, a symbol of athleticism, of adventure, and of mobility. This is my dream for amputees, and especially if you have options. In the developed world, I have a knee joint here in my hand. It's a knee joint like this can cost $5,000 made out of titanium. But in the developing world, where there are less options, this can be very difficult. So, to understand the problem of amputees in the poor countries, we traveled to India, to Jaipur, where we met many amputees. Here you see some amputees that are missing their legs above the knee joint. They're using bamboo staffs to get around. And one amputee that we met that inspired us, his name was Kamal. Here you see Kamal with his bamboo staff. He's a 16-year-old boy in this picture. He lost his leg in a motorcycle accident the year before. When we looked at his hands, they were full of calluses from carrying himself around on this bamboo staff, and his spine had warped from the awkward way of moving. We decided that Kamal should be able to live a better life, and myself as an engineer at Stanford University, I thought I could do something about this. So this was really our beginning into prosthetics and our mission to empower amputees to go beyond their natural limits, to live up to their full potential. And by making prosthetics more affordable, we hope to bring Kamal his dreams. So to give you an example of what options you have when you're a poor amputee, especially in India, I will show one example of a knee joint. This is called single axis. This is like a door hinge would swing. It has one axis. And you can see this young amputee is learning to walk on this type of knee joint, which is very poor performance. He almost falls. It's very unstable. Mechanically, psychologically, emotionally, this takes a long time to learn and be confident. This is very cheap. This is a $30 knee joint, $20 to $30. But it is not acceptable for an amputee when we can engineer better solutions at similar cost. This is another type of prosthetic. This is if you don't have a knee joint, it is locked like a stiff leg. This type of walking, you can see, looks very awkward. It's very exhausting to walk on a leg that is not flexible. So for many amputees, it is not an option, I think, to have a non-articulating leg. So that is why we designed what we call the Jaipur knee. And this was in collaboration with a partner in India, the Jaipur Foot Organization, a famous NGO that had developed low-cost feet. For 30 years, they had been doing prosthetics. And we innovated the knee joint. It uses a special kind of mechanism, the same kind of mechanism in this very expensive titanium knee joint. We were able to change the material to be made of polymers, plastic, nylon. And that reduced the cost with some careful engineering to $20 US. And so with the Jaipur knee, we were able to reduce the cost significantly and maintain performance. This is a very stable knee joint. And I'll show you Kamal, the same one earlier, walking with this improved knee joint. He is the first patient to be fitted with the Jaipur knee. This is in 2008. With a prosthetic limb, he does not need to use a staff. His hands are free, and he can walk confidently, upright, with natural gait. And this is a vast improvement over the alternatives that I showed you. As a mechanical engineer at Stanford, this was the proudest moment of my engineering life. To make something that was helping somebody's life. And we were very proud to have gotten a lot of attention for this kind of innovation, being featured in press in the US like Time Magazine, CNN, Business Week, for example. But this story of Kamal is not just a proud moment, it's also a very sad moment for me, because it's not enough to impact just one life when the need is so great and we have the potential to make much larger change. With over 20 million amputees in the developing world and the rates increasing by hundreds of thousands every year due to accidents, trauma, road vehicle, train vehicle accidents, diabetes, and war. This is a problem that is not going to disappear. So we turned our attention to scaling this innovation. And this is where we became social entrepreneurs, going from inventors and engineers to entrepreneurs. And currently, this is an old slide. We have 2,250 patients, over 2,000 patients in India fitted with the Jaipur knee. And our goal with Remotion is to repeat this model and scale, not just India, but globally. And in doing so, we will create jobs, we will re-empower amputees, and we will create a social impact that goes much beyond the money that somebody would be earning, increased money they would be earning from having mobility. So that's Remotion's story, and we're partnering with NGOs in different countries. But I want to give you a few examples of our process of how we invented the Jaipur knee and continue to invent ways to stay sustainable and impact human lives at high scale. We see innovation as a combination of technology, of business, and also of human values, that is putting the human at our center of our process. And we use a process that we call design thinking that I've been teaching at Stanford, which is a method of creativity, of solving problems repeatedly. People often think that creativity is something that is only for the genius or the few. But I say creativity can be taught, and we see it every day in Silicon Valley. And so the method of how is very important. It starts with empathy. I mentioned the story of Kamal because without understanding Kamal's needs very deeply as a human, we will be unable to design an engineering solution. It's important to understand the culture in India where many amputees walk barefooted, many amputees need to squat to use a restroom. There are important cultural considerations. Many engineers often forget this step of becoming immersed in the culture and understanding what the needs are. Then comes the familiar. As an engineer, this is what I'm trained to do, understanding the technical literature, the language of prosthetics and biology and mechanical engineering. So we combine all these things, a knowledge of biology, of empathy, human understanding, and we define a focus that we will focus on solving Kamal's problem. We call this stage the define stage. So now we are going on to the third stage of our process, which we call ideating, which is coming up with ideas for specific ideas for the problems that we're seeing. And here we see some students brainstorming. And this is a concept where we come up with as many ideas, thousands of ideas, to solve a specific problem. And notice the order that I show these highlights, starting with an understanding of the problem, focusing, and then we are doing the brainstorming and what people often consider as the creative stage. We move on to the fourth stage, prototyping. And by prototype, I mean a very early, low resolution, low effort, very quick things that we make to answer the questions very quickly. So this is the first Jaiprani that was made. This is made out of cardboard. And we made it in 15 minutes. And the goal of our session that day was to answer a question. Can we make a polycentric knee joint that flexes? And we answered that with some scissors and cardboard in 15 minutes. So when I say prototyping, this is a very useful tool early on in our process to use rough and rapid methods to answer our questions. Later on, we fabricated more complex devices, but only after doing very quick 15-minute rough prototypes. And here we even use even more complex tools like computer-simulated finite element analysis. So as an engineer, it's surprising that often these solutions that are before the more complex tools are things like cardboard and duct tape and scissors. And that, I think, is a powerful thing that we learn in our process before jumping to hours or days or weeks or months of analysis and research. And then we test these ideas, the final stage. There's one of my teammates in the lab. This is Eric. And we are cycling a knee joint on a machine in the laboratory. And he's having fun. This knee joint we cycled 3 million times in the laboratory. And here we see us trying to break a knee joint with 700 pounds of force on it. It did not break. We have not been able to break a knee joint to date. We have not been able to break a knee joint in the field after 2 years of field testing. Things are looking very positive for this technology. And nothing can compare to testing on a human. And so we have brave volunteers who try our designs as soon as we come up with them, and they're very fearless, and we admire that. And so I point this out that after understanding the problem, coming up with solutions, prototyping solutions, testing is essential to do this design cycle. And we call it a cycle because we don't do this once, we don't even do it in the same order every time, but we do make sure that many of the steps that I showed you today are done, and done quickly, rapidly, over and over and over. Our goal is to do this cycle, the design cycle, as many times as possible. So I would leave you with 3 major learnings, takeaways. It is less important about what you create, what innovations and fantastic technology. It is perhaps even more essential as social entrepreneurs that we think about how we go about innovating. The method, the repeatable method of innovation. In our case, we call this design thinking, but we all have a different process to share, and we can learn from each other. And I think together, we can learn from each other's processes. One thing I'll note, none of these things I showed you were done alone. All of them were done as a team. It is impossible to innovate radically without strong collaboration. My teammate Eric, others at Stanford, we need radical collaboration as social entrepreneurs to solve complex problems. And lastly, always having a center on the human. All of our designs stem from an understanding of human needs, and it is around our human needs that we focus, not on technology, not on business, but around human needs and desires. We don't want to solve a problem that doesn't stem from a human need. And so, with these things, I would say there's no one perfect way to innovate or to design something, but I do believe it is most important for designers, innovators, entrepreneurs, people who want to make change makers, to be mindful, to be aware of how we innovate so that we might learn better from our own processes for self-reflection and also share with each other like we are doing today. So with that, I thank you, and I hope you could learn from some of our lessons, and I hope to learn from you.
Good afternoon, friends, and namaste. After an excellent speaker who articulated himself so well with fantastic slides and touching story, I have a very big competition. I think I will not be able to fulfill expectations, and I have one more problem. I cannot speak slowly. Because if I try to speak slowly, I forget what I have to tell. But I will still try. There is some mistake in the booklet because in my today's presentation I'm going to talk of biogas technology, which we have also developed through another company called Excellent Renewable. I was introduced as a solar company person. Yes, I started my career with solar energy, but soon realized that when you talk of renewable technology, we need to involve and make systems hybrid so that you can get technology or energy even when the sun is not there. And this is what biogas offers. Next, please. Normally when you talk of biogas, people always confuse biogas with cow dung because they think that biogas is a technology where you have a cow dung, and when you put them into a tank and then let it ferment, and it gives you a gas which is called methane, which can be used for cooking. It is true. Biogas did start with cow dung, and even if you were to just look at the statistics here, in India we could produce more than 5,000 megawatt of power from cow dung alone. India has 3% of the world land area, but we have 15% of the animal population. And out of that, only 5% of the potential has been tapped. But biogas, as I will try to show you, is more than just from cow dung. It could be used for many other material. Here you can see it could be from waste, from sugar factory, paper industries, milk industries, starch industries around. Next, please. I again came into the field of biogas because I come from solar energy and I'm supposed to be a cooking person. I have supplied systems for solar cooking, and the world's largest solar cooking system I have supplied, I'm going to talk about tomorrow, is which cooks for 50,000 people. So I realized that yes, I love food, that's why I'm fat. And I also know that whenever you have food, you also have food waste. So why can't we use the food waste also? But when you talk of food itself, I was really shocked to learn that 50% of the world population, not India, 50% of the world population cooks on open fire. And cooking with wood, that is, which creates smoke in the kitchen. Smoke in the kitchen is the third world's largest killer. It's not AIDS, it's not tuberculosis. The first world's biggest largest killer is the car accidents. Car has killed more people than the First and Second World War together. Then it is the diseases, and third is the smoke in the kitchen. But because smoke is not seen, it's called a silent killer. If you go to India, there are two distinct features you will see in villages. 70% of the village population in India lives in villages. So if you go to a village, you will see an Indian woman either she's carrying wood or she's carrying water. So collecting wood is the biggest problem, and this is the way, as I said, 50% of the world population cooks with pure wood. Next, please. So initially in India, way back about 50 years ago, some people had started working on biogas, and biogas was developed in India, where they used to take the cow dung from animals. As I said, we had enough cows, and that's why often people say the Indian holy cow, because you see them on the islands, on the road centers and all, but they are also installed. Next, please. And in early days, people would have a biogas like this, where there was a tank where they would just put the cow dung mixing with water. It would ferment, and the gas would be piped into the kitchen, and the slurry will come out, and it will be used as fertilizer. Next. So this is where you see they take the slurry out of the biogas after it has already given the gas out, and which is then taken to a pit where they put earthworms, and with that with the earthworms, you create fertilizers. And the fertilizer which you get is organic fertilizer, which is an alternative to chemical fertilizer. Next, please. The fertilizer has very high NPK value, that is nitrogen, phosphorus and calcium. And in India, more than 21 million tons could be displaced. All these chemicals is produced from oil, so why not go the organic way? Next. But the problem that is happening now in India is that in spite of all the poverty, there is some prosperity happening at the village level. And the moment people start getting a bit richer, they don't want to live traditionally. The poor woman who did not mind going and collecting the cow dung or making the house of the cow dung does not want to use cow dung because she thinks it's dirty. It's not, but then it's the mindset. We have started putting wrong values to the wrong things. So now she doesn't want cow dung, she doesn't want to have animal because it changes her life, it forces her to get up at 4 in the morning, she cannot go for holidays. It's like having a dog, so she didn't want that. So now the government said, why don't we now create community biogas plant where instead of every household having a biogas, people in the villages who have their cows bring the cow dung. You have a community biogas plant where you put the cow dung into the tank and the gas is then piped to the villages. A great idea, but it did not work. And why it did not work? Because the government forgot that tank, like water tank, anyone who is near the tank will get water at higher pressure, and the one which is at the far end will get lower pressure. So the people in the villages objected that I bring my cow dung, he brings the cow dung, he gets more gas than I. So the technology started failing. The people's participation did not take place. And that's where we started working on innovations. Next. So basically what we realized was that biogas technology was not a technology, just a simple technology. You have to whole cycle, you have to understand the whole process. So basically the first process, as I said, is you have to have animal or any other waste. You have to collect it, you have to purchase it. Okay, so basically what we realized in villages was that if you rely on people to bring the cow dung, and some people bring and some people not, but everyone gets a gas, then people will say, why should I get gas free when, why the other gets free when I am also bringing cow dung, he is not bringing cow dung. So basically we said, okay, we'll buy the cow dung from the people. And the advantage what we saw was that the cow dung which was lying away in far off fields where no one wanted to bring it, the children would go and collect it to get some pocket money. So the cow dung became a resource, which is a raw material. And then you take the gas. And then what we did as an innovation was we put a pressure regulating tank. So we started pressurizing the gas. Now because of that closed loop, all the villages which were connected with would get the gas at the same pressure, and gas would be used for cooking, and then the slurry will go out and go into fertilizers, and the fertilizer will again grow grass or animal feed, and again it's a closed cycle. So basically we realized that you need to tap into the natural resources and create an organic cycle where you don't depend on external resources. Next. So I will just show you some photographs of some projects which we have done. This is the first project which we did in 2007. In this village, we have these 2 tanks where the biogas is produced. Each tank has got 85 cubic meter gas generation capacity. The gas is then taken to this red tank, which is the pressurizing tank, where the gas is pressurized. And we started working on appropriate technology. Means there are various ways of doing all these things. But our idea was, for me, the definition of appropriate technology is a technology which can be made with local raw material, locally available skills. It should be installed by local people, it should be operated by local people, and it should be repaired by local people. So these are the 5 important features of appropriate technology. So as you see, everything is very simple, all made from metal, just simple welding technology, knowledge is sufficient. You have a regulating pressure regulator tank, which is nothing but with the water we create the pressure, so it's a water-based pressurized tank. And then the whole pipe was gas to 120 whole households. So one whole village is now getting pipe gas, just like in big cities now you have got pipe gas, now people are buying gas from Russia to India. Why can't you use the local resource, which is the waste, and convert it into wealth by giving you gas and audio fertilizer? So this was the first project. Next. So here, this is the schematic which actually shows it, which I explained, that you put a raw material, you get the biogas, you pressurize it, and then send it to the household. Next. Then we realize India has 1.2 billion people. And as I said, whenever you eat something, you also have to do some waste out of it, that's human waste. And actually you can also convert biogas from human waste. So these are the projects which are in villages, because in India, because of poverty, not every household has got toilets. So normally people are then forced to go outside in nature, and then it's the women who have to suffer the most. So people started working on community toilets, where they say, okay, people cannot afford to have individual toilets. Then in a village you have a place where people can go and go to toilet. But then the sewage was becoming a problem. What do you do with that? So we started taking the sewage and then putting it to the biogas tank, and then biogas out of it. So this is the village where we are supplying gas to 60 households. So we realized that cow dung, besides cow dung, even the human dung could also be used for producing gas and fertilizers. Next. Then we started asking ourselves, why are we restricting ourselves to only what comes out from human beings or animals? Why can't we take the natural resource? Because biogas is nothing but anything which is biodegradable will give you a gas. So we started looking at different materials, and then here we created another technology called modified USAB, where you can put any raw material. It could be kitchen waste, it could be factory waste from food factories, it could be municipal waste, and then you can produce biogas out of it. So this is a plant for 250 cubic meter. But the problem we started facing was that the place where you now generate this biogas is very far away from where you use it. And it was not possible to pipe it, because the place where we wanted to use it was 40 kilometers away. So we said, now we have to find some different solution, because to lay a pipe of 40 kilometers is expensive. You have to go through the land of many people, which many people do not want, because the very word gas, which is combustible, creates a lot of fear. So we devised a new technology. Next. Basically, we said, why can't we take the gas and put them into the bottle, just like the LPG cylinders come? But then we also realized as a chemist that when you have a biogas, you have got only 65% methane in that, you've got about 20 to 25% carbon dioxide. So we did a simple technology. We put the gas into a big tank or a column. You spray water from it, the water gets dissolved, or the CO2 gets dissolved in the water, and that gas becomes enriched, and that enriched gas can be then compressed. Next. And then so after removing the CO2, we fill the gas into the bottles, and then these bottles are taken to the ashram for cooking. So we cook for about 1,200 people with biogas, which is now traveled or transported 40 kilometers from the place where it was generated. Next. And we suddenly realized that, if you look at the circle here, it's a biogas. Once you remove the CO2, the methane content becomes about 91 to 94%, which is nothing but a compressed natural gas. And we knew that all of a sudden there we had a technology, because worldwide, like in Sweden, I think 64% of the cars are driven by compressed natural gas. So we said, why can't we use biogas not just for cooking, but also for other applications? Next. So we are using the biogas now for driving the vehicles. And suddenly we said, wow, if we have this technology where the raw material comes from the villages, where the technology can be manufactured, operated, maintained, and repaired by the local people, why can't we convert our villages into refineries, where villagers can grow their own food, they can grow excess raw material for producing biogas, and they can start exporting fuel. First we need to identify places where we can do it. Then we have to look at the prospect, then we have to implement the project, and then we have to monitor and maintain it. Next, please. And what we also realized was that it was very important that there is a one-point agency, because the moment you start having too many agencies involved, there is a fight, because there is no clear line whose work it is, and we start blaming each other. In spite of that, let there be a single agency which can implement everything. Next. This again summarizing the same. Next. Again, it is going into too much of technical details where you have a feeding mechanism, you have got gas generation system, you have got gas distribution system, and you have got gas enrichment system. Government is now very excited about the whole process. We have been given in Gujarat state 26 districts, where in each district government wants that we take a village and prove that this model works in different climatic zones, in different raw materials, and government is giving subsidy as high as 80%. So sometimes your government can also become your partner, because for them government, it was not just supplying energy, but it was also taking care of the waste which was in the village. Because unfortunately, this is the price of prosperity. The more prosperity you come, the more waste we generate, and that's how we need to solve the problem. Yes, please. Next. We are also working on municipal solid waste. Next. Now, the latest what we have done is we have created a mobile biogas plant, which is in container. So just like a computer, it's a plug-and-play system. You can build the biogas plant, take it to the place, take the raw material, generate the biogas there, and move on to the next place. Next. So earlier, whenever you would think of cooking, you would see all those problems, which was deforestation, pollution, and global warming, and then health hazards. But now the same lady you can see cooking in the comforts of the kitchen without any smoke. So let us all work together, let us learn from each other. I'm glad that I'm here, and I would be glad if I can share all my experience with you all. Thank you very much.